Lesson 37, Using Scientific Notation. So we've talked before about negative exponents. The negative means a reciprocal, and then you change the exponent to positive once you do the reciprocal. So this is 1 over 1,000, or 1,000th. Now, a scientific notation is a number written as the product of two factors in the form a times 10 to the nth power, where a is between 0 and 10 and n is an integer. So we're going to write the definition for scientific notation. It's a number written as the product of two factors in the form a times 10 to the nth power. The times symbol, we use an x. In scientific notation, every time we use an x. Where 1 is less than or equal to a, which is less than 10. So your number here must be between 1 and 10, not including 10, but it could be equal to 1. And n has to be an integer. So it can be positive, negative, not necessarily 0. So here's an example, and we say it 5.8 times 10 to the 4th. And this is in scientific notation. Because if you notice right here, 5.8 is between 1 and 10, not including 10, but including 1. 25.3 times 10 to the negative third. The a here, the 25.3, is not within these parameters, so this is not in scientific notation. So when we write a number, just any number, it's called standard form. So 856,000, that's considered standard form. We can change and take the same number and write it in scientific notation, and they will be the same. So we bring our decimal to the right of the 8 so that we have a number between 1 and 10. And then we figure out, what do we have to multiply 10 by to get 856,000? Well, if you notice, we move the decimal 1, 2, 3, 4, 5 places. So if we did 10 to the 5th, we would get back our 856,000. So this one is the scientific notation. Now when you're multiplying and dividing scientific numbers, here we'll just write this down. First you multiply or divide the number parts. That's the part that's the letter A. Here, that comes right before the times 10 to the power. So we're going to multiply or divide, whatever the sign tells us to do, the number parts of the scientific notation. Then we add or subtract the exponents dependent on if we're multiplying or dividing. So the exponents on 10, the n here, we add if we're multiplying two scientific numbers, and we'll subtract the exponents if we're dividing two numbers in scientific notation. And the last step is to make sure your final answer is in scientific notation. Unless you're told to put it in standard form, If you're multiplying or dividing numbers in scientific notation, you want the answer to be in scientific notation. So here's an example of multiplying two numbers in scientific notation. 5.7 times 10 to the 5th times 1.8 times 10 to the 3rd. Now, we can use the commutative property. All four of these numbers are being multiplied. So we could switch orders. We're going to switch these two right here. We're going to get the 10's powers together and the number parts together. So we have 5.7 times 1.8 times 10 to the 5th times 10 to the 3rd. Because we're multiplying, we're going to add the exponents here. When we multiply 5.7 times 1.8, we get 10.26, and then we can say times 10 to the 8th when we add the 5 and 3. This is not in scientific notation. We need to move the decimal to the left one, so then we need to move the number to the right on the number line. So this is times 10 to the 9th. So if you move left on your number, then you move right on the number line for the exponent. So here's an example of dividing. We're going to divide 1.2 times 10 cubed, 10 to the 3rd, divided by 9.6 times 10 to the 6th. So we're going to divide the number parts, and then we're going to divide the powers of 10, which to divide powers of 10, we're going to subtract exponents. So 1.2 divided by 9.6 is 125 thousandths, and we subtract 3 minus 6 is negative 3. Now we need to move the decimal to the right. So if we move the decimal to the right, we need to move the exponent to the left on the number line. So we have 1.25 times 10 to the negative 4th. So there's a couple of things to remember when we're multiplying or dividing and we're trying to change from a number that's not in scientific notation to a number that is in scientific notation. If you have to move the decimal to the left, we want to add to the exponent, however many places we moved it. Then if you have to move the decimal to the right, then you're going to subtract the number of times you move it from the exponent. That's the end of the lesson.